All right, everybody. So we're going to start with the celestial objects question. We're going to start with number one. So it says the photograph below shows an impact crater. All right, we're going to have to remember this, an impact crater located in the southwestern United States. This crater, all right, most likely formed as a result of what? So this is a conceptual question that you just need to just know, all right? A lot of craters that are created on Earth came from a meteor. All right, meteor. Sometimes you have problems that may also mention it as an asteroid as well. All right. So the meteor or the asteroid, they impacted the Earth, which is why we call it an impact crater. All right. And so the option that shows that best is choice C, asteroid colliding with Earth. All right, number two, it says, which two characteristics classify Jupiter as a Jovian planet? All right, so you know there are two different types of planet. There are Jovian and there are terrestrial. All right, and so therefore we actually taken notes in class, and so this is something that you could have used page 15 of the reference tables, or you could have just used your notes. And so right here shows us the different characteristics of a terrestrial planet and a Jovian planet. Okay. And so we know that Jovian planets are large, far from the sun, made only of gas, low in density, have many moons and rings. And so when we go back to the problem, we know that if you are large, right? If you're a planet that is large in size also means that you have a large diameter. Right? Diameter speaks about the width, right? The measurement of width. And so large size means large diameter. All right. And so therefore, as we just saw on the PowerPoint, we've noticed, and I'll flip back to the screen, we've noticed that Jovian planets are low in density, low in density. And so because they're low in density, right, that's also going to help us with our problem. And so when we switch back, low in density and large diameter gives you choice A. All right, so number three, they give us this diagram that shows a representation of the sun and some object that is orbiting the sun. So it says the arrangement and movements of celestial objects in our solar system, all right, in our solar system, currently right now, is best described as what? Well, once we know that objects are orbiting the sun, which is key, if objects are orbiting the sun, then we know that this is a heliocentric model, all right, where objects orbit the sun, okay? If it was a geocentric model, then that means that the objects would orbit the Earth. But because of the fact that they're talking about our solar system, and we clearly see that the sun is in the center, then therefore it has to be a heliocentric model, which is why the correct answer is choice D. Number four, it says, base your answer to the following question on your knowledge of Earth science. The diagram represents one position of Earth in its orbit around the sun and 12 constellations that can be seen in the night sky by an observer in New York State at different times of the year. The approximate locations of the constellations in relation to Earth's orbit are shown. Point A represents another position in Earth's orbit. All right. And so it says, approximately how many days does it take for the Earth to orbit from its present position to point A? So there's some things that we do need to know. All right. The Earth, right? The Earth completes this entire pathway. In how many days does the Earth does one full revolution? One full revolution for the Earth is equal to 365 days. All right. So for the Earth to do one path, the Earth to do one complete path back to where it is again, that means it's going to take 365 days, right? However, one thing that's very interesting is the fact that the Earth only takes from the Earth to position A is only halfway through its path, right? So instead of completing a full path, the full orbit, which would be 365 days, instead the Earth just takes a path that's about halfway to A. So that means that I need to pick how many days does it take for the Earth to orbit from its present position to A. I need to know what is half that time period. So 365 days is for the full rotation. Divided by 2 lets me know of how long it will take to complete half of its revolution. Sorry, I meant to say revolution. And so 365 days divided by 2 gives you 182.5 days. And so because of the fact that from here to here takes 182.5 days, I'm going to choose the best, closest answer, which ends up being choice C. 182.5 days is closest to 183 days. All right, so for number 7, the next question. So it's stating that most asteroids, here you go. It says most asteroids form in a belt located between 329 million and 478.7 million kilometers from the sun. Identify the 2 planets located on either side of the asteroid belt. So just from pure memorization from our notes, we know that the asteroid belt is actually between 2 planets, Mars and Jupiter. Is between the orbits of 2 planets, Mars and Jupiter. So the 2 planets on either side of the asteroid belt is Mars and Jupiter, right? So Mars and Jupiter would have been your answer. That's one way to get it. The second way to get this answer is if they tell you that the formed in the belt located between 329 million and 478.7 million kilometers from the sun. All right. When I'm looking at those numbers, and I'm going to change my screen to my reference tables, right? If you go to page 15, and you're looking at the solar system data chart, when I look back at those numbers again, I see that it says 329 million and 478.7 million. I'm going to go back 329 million and 478. If you notice, 329 million and 478.1 million, both of these numbers fit in between 227 and 778. And so because of the fact that both of these numbers fit in between 227.9 and 778, that lets you know that the asteroid belt is also between Mars and Jupiter. So that's why the correct answer, once again, the two planets is Mars and Jupiter. All right, so it says, base their answers to question 5 and 6. So letting you know the diagram below and on your knowledge of Earth science. So these diagrams right here, you may possibly need them for questions 5 and 6. So keep that in mind. The diagram represents 5 inferred stages in the formation of our solar system. Stage 1 represents a contracting gas cloud. Stages 2 to 4 represent the gas cloud flattening into a spinning disk as planets formed around our sun. Stage 5 represents the final stage in the formation of the solar system. All right, let's keep that in mind. So let's take a look at number 5. So number 5 says, compared to the terrestrial planets that form closer to the sun, describe how many? 2 characteristics that are different for the Jovian planet that formed farther from the sun. Compared to the terrestrial planet, that's what we're comparing it to. We are describing 2 characteristics that are different for the Jovian planets. So our description is going to be about Jovian planets, not terrestrial planets. Our description is going to be about Jovian planets in comparison to terrestrial planets, all right? And in one of the previous videos, I showed you that list. I showed you the different characteristics, and so you had to pick 2 of them. So if we see our answers here, oops, sorry. We take a look at our answers, and this was for number 5. I apologize. Here we go. All right. And for number 5, you could have said any of these options right here. You could have said the Jovian planets formed from less dense materials. The Jovian planets are larger, have great equatorial diameter. Jovian planets are composed of gaseous material, greater period of revolution, shorter period of rotation, greater mass. They're colder because they're farther from the sun. They have a large number of moons. Jovian planets also have rings. Any 2 of these options would be fine. So if you want to pause the video just to compare to see if your answer is correct, that is perfectly fine. And once again, we're referring to the fact that we know what the characteristics of Jovian planets are and what the characteristics of terrestrial planets are. As for number 5. All right. So number 6 says, identify the planet in stage 5 that has a period of rotation greater than its period of revolution. Well, when I read the background information, they tell me right here that stage 5 represents the final stage of the formation of the solar system. So stage 5 is a picture of our solar system. So the planets that we're going to be choosing are planets from our solar system. And so now, what page of the reference tables, if we take a look, what page of the reference tables talks about the planet's characteristics that can help us? What page of the reference table talks about a planet's period of rotation and its period of revolution? That's right, everybody. It is page 15. So if you turn to page 15 of your reference tables, right, the solar system data, that's what we're looking at, the solar system data. And now we go back to the problem, and it tells us, identify the planet in stage 5 as a period of rotation greater, keyword greater, than its period of revolution. So that means that we're looking for a planet. We're looking for a planet where the period of rotation is bigger than the period of revolution. All right, so we're looking for a planet where this category, the period of rotation, is bigger than the period of revolution. So when I take a look, so Mercury has period of revolution 88 days, period of rotation 59 days. The period of rotation is not bigger than the period of revolution. So Mercury does not count. Let's look at Venus. Venus has a period of revolution of 224.7 days. Venus period of rotation is 243 days. This number, 243 days, the period of rotation, is bigger than this number. And so because the period of rotation number is bigger here than it is at the period of revolution, Venus is our correct answer. Venus is the only planet where the period of rotation is bigger than the period of revolution. So it says basic answers to questions 8 through 10 on the diagram below. So that means on the diagram and passage below, we're going to be answering, it can help us to answer questions 8 through 10. And on your knowledge of Earth science. The diagram represents the orbit of Earth, the common temple turtle, and planet X, another planet in our solar system. Arrows on each orbit represent the direction of movement. All right. So, sorry. So it says, let's do the reading very quickly. It says common temple turtles orbits our sun and is responsible for the Leonid meteor shower event. Ooh, sorry. Observed from Earth. This meteor shower occurs every year in November and is visible in the night sky as Earth passes through debris left in space by this comet. This debris from the comet produces meteors that are smaller than a grain of sand, which enter Earth's atmosphere and burns up in the mesosphere temperature zone. Common temple turtle orbital distance from the sun ranges about 145 million kilometers at its closest approach to 2,900 million kilometers at its farthest distance. Every time I see numbers, you just want to just highlight that, right? What do these numbers mean? 145 million kilometers at its closest approach and 2,900 million kilometers at its farthest distance. All right, let's keep that in mind. Its two most recent closest approaches to the sun occurred in 1965 and one revolution later in 1988. So number 8 says, identify the solar system planet represented by planet X, which orbits near Common Temple's turtle's farthest distance from the sun. So the reading told us that the comet's distance, when it's farthest from the sun, it says it right here, 2,900 million kilometers at its farthest distance. 2,900 million kilometers at its farthest distance. So identify the solar system planet represented by planet X, which orbits near the comet at its farthest distance from the sun. So that lets me know I need to find a planet whose distance from the sun has to be about 2,900 million kilometers. All right, so that's something to keep in mind. 2,900 million kilometers. So what page of the reference tables am I going? I am going to page 15. And so I'm looking for which planet is closest to where the average distance from the sun is closest to 2,900 million kilometers. When I'm scanning, the one planet that has the closest to 2,900 million kilometers is Uranus at 2,871. So as you can see, 2,871 is very close to 2,900. And so Uranus is the correct answer. All right, number 9. So number 9 says, determine the year in which Common Temple Turtle will make its its closest approach will next make its closest approach to the sun. All right. So that's letting me know somewhere in this reading is giving me information as to how is this comet going around the sun repeatedly, right? So there must be some pattern that's taking place. When I look at the reading, one thing that's interesting, it tells me its two most recent closest approaches to the sun. And sometimes when you're doing a reading, you may have to even just look at similar words, right? That can help us in the question. So the question say, right, it closest approach to the sun, and it says the two most recent closest approaches to the sun occurred in 1965 and 1998. And so this pattern must be repeating itself. So if the first one occurred in 1965 and the next one occurred in 1988, right? Then I have to find out when will the next one occur. Okay. So therefore, what I'm going to do is I'm going to subtract. So I need to know how far is 1998 from 1965. And when I subtract, I find that they are 33 years apart. All right? They're 33 years apart. Am I done? No, I am not. Why? Because the question is saying determine the year, right? 33 years just lets me know how often is this comet being closest to the sun. 33 years is not telling me the actual year in which the comet will next make its approaches to the sun. So now that I know it's 33 years, I know the most recent one was at 1988, and I need to know what year is it going to be 33 years later. And when I add, so when I add the 1, carry the 1, this turns to 10, 3, this turns to 20, right? And 1998 plus 33 gives us the year 2031. And so that is your answer. The next time the comet will make its closest approach to the sun is the year 2031. All right, number 10. So it says, identify the force that causes debris from the comet to fall through Earth's atmosphere, right? So we know that as a comet is passing by, there are some pieces from that comet, right, that can break off, right? And some of these pieces, right, debris, they can fall right through to the Earth's atmosphere. Okay, this is the comet. All right, the debris that comes from the comet that falls through to the Earth's atmosphere. The question is, what is the force that causes debris from the comet to fall through Earth's atmosphere? It is the only natural, right, attractive force. There's only one natural attractive force, and this force is responsible for a lot of just movements that's going on in space. It plays a role with the creation of stars, and that force is called gravity, right? If something is naturally going from one place to another, there's a very good chance that gravity plays a role with it. And that is your answer for number 10. Number 11. So it says, base your answers to questions 11 to 13 on the models below and on your knowledge of earth science. So once again, these models and these diagram below is going to help us, that could possibly help us not only just for number 11, but 11 to 13. Keep that in mind. Make sure that you're always reading. The models represent cutaway views of 4 planets in our solar system, showing their inferred interior structure. each planet is shown in relation to the size of Earth. Okay. So we have Mercury, Venus. We have Earth, right? Earth is everywhere. And we have Jupiter and Saturn. All right. So number 11, just looking at number 11. So number 11 says, determine how many times larger Jupiter's equatorial diameter is compared to the Earth's equatorial diameter. All right. So there's one page on the reference tables that has a whole bunch of facts about our planets and can possibly even include information about Jupiter's equatorial diameter and Earth's equatorial diameter. What page, everybody, is it? Page 15. Let's go to page 15. All right. So see Jupiter and its equatorial diameter is 142,984 kilometers. Earth equatorial diameter is 12,756. And so therefore, what I'm going to do to find out how many times larger is Jupiter's diameter from Earth is, I'm going to divide these two numbers. Now keep in mind, because Jupiter is bigger than Earth, my number has to be bigger than 1. All right? Because Jupiter is bigger than Earth, my number has to be bigger than 1. So if you're dividing these numbers and you divide it the wrong way, you get a decimal, that lets you know that you've divided it the wrong way. So when I go on my calculator and I'm going to divide 142,984 divided by 12,756, right? Because I want to know how many more times larger is Jupiter's diameter from Earth. When you divide, and I'm just going to my calculator, 142,984 divided by 12,756. And I'm just rounding to the nearest tenth. You end up getting 11.2. All right, times larger. Okay. And so that is an acceptable answer. If you look on the answer sheet, right, if you got 11.2, that's fine. If you look on the answer sheet, and this is for number 11, one thing that you'll notice is right here. Oh, sorry. It says if you got to answer 11 to 12 times larger, then that is fine. All right. So if you said 11.2, if you got an answer between 11 to 12 times larger, you are correct. So number 12, it says, explain why Jupiter appears brighter in the night sky than Mercury, despite Jupiter's greater distance from Earth. All right. So as you can see in the notation, I actually wrote this down and I forgot to hit record, so it's perfectly fine. So one main difference between Mercury and Jupiter, right? As you can see, Mercury is much smaller than Earth. However, Earth Earth is much smaller than Jupiter. So therefore, the only conclusion I can make is that Jupiter is much larger than Mercury. All right, Jupiter is much larger than Mercury. And so therefore, there's something that we learned that is new today. And it is the fact that larger objects appear brighter, right? Larger objects appear brighter than smaller objects. Larger objects appear brighter than smaller objects. And that is your answer for number 11. All right, number 13. So number 13 says, Identify 2 terrestrial planets shown in the model. Explain why they are considered terrestrial planets, all right? Well, if you've forgotten, and I'm here to remind you, the terrestrial planets are the first 4 planets from the sun in our solar system. So the first 4 planets from the sun, they are all terrestrial planets. They are all terrestrial planets, okay? Now, keep in mind, when we go back to the problem mentioned that they only want to identify 2 terrestrial planets shown in the model, all right? So even though we identified Mercury, Venus, Earth, and Mars, you cannot write Mars as an answer, because the question only asks, this is why we got to make sure to read. The question only asks, identify 2 terrestrial planets shown in the models. So we head up. The terrestrial planets that we see is Mercury, Venus, and Earth, right? We do not see Mars. So if you said Mars, you would have been incorrect. Mercury, Venus, and Earth. All right. And so the question talks and says, identify 2 terrestrial planets shown in the model. Explain why they are considered terrestrial planets. So we could go back to our chart in our notes, right, that we've copied down. And if you mention 2 of these characteristics, any 2 of these would be fine. All right. Any 2 of these would be fine, right? If you say that they're small, they're closer to the sun, they're made of rock, dense, have few moons, and no rings, all right, that would have been fine as well. I'm also going to switch to the answer sheet, so that way you can see what other answers that would be acceptable. Oh, there we go. Sorry. All right. All right. So once again, you notice Mars is not here because Mars was not one of the models that was shown. All right. And any of these explanations are fine. Any of these explanations are fine. You can pause it just to see. All right. And to compare with the answers that you have. All right, so it says, base your answers to question 14 and 15. So once again, on the passage and diagram below. So the passage and diagram below can help us with question 14 and 15. All right, on the diagram below and on the data table and on your knowledge of earth science. All right. That means that your reference tables could help as well. It may not help, or it could help. The diagram compares the inner planets of our solar system to the planetary system surrounding the star Kepler-62, which is located in our galaxy. This data table shows some data for the planets in the Kepler-62 system. All right, and then we're going to read about the Kepler-62 system. 5 planets orbit a 7 billion-year-old star, Kepler-62, which has a surface temperature of approximately 4,900 Kelvin. 2 of these planets are located within the habitable zone, which is the region around a star where life may exist due to the possible presence of water in the liquid phase. The shaded areas in the orbital diagrams below indicate the habitable zone of each system. All right. So, and as we take a look, we see the shaded zone. We see the non-shaded zone. All right. Shaded zone, non-shaded zone. All right. Obviously, we see this is our own system. Right up here is Kepler-62. And this is the inner part of our solar system. Okay. So and then we have a data table that's given right here as well. All right. So it says, identify the name of the planet in our solar system that has an equatorial diameter, most similar in size to the equatorial diameter of planets Kepler 62c. So we're looking for the name of the planet in our solar system that has an equatorial diameter who's most similar in size to the equatorial diameter of Kepler 62c. All right. So when I take a look at Kepler 62c, this is the planet. All right. And at Kepler 62c, I'm looking at the equatorial diameter because that is what the question is asking for, equatorial diameter. All right. And this equatorial diameter is compared to Earth's diameter. All right. So this is either some number of times compared to Earth's diameter. And so it says 62c has an equatorial diameter that's 0.54 times Earth's diameter. So we have to find out what is Earth's diameter. All right. So let's look on page 15 of the reference tables. Oops. So when I look on page 15 of the reference tables, Earth's diameter is 12,756. All right, equatorial diameter 12,756. All right, remember that number, 12,756. I'm just going to write that on the side, 12,756. All right. So Kepler 62c is 0.54 times that number for Kepler 62c. So 12,756 times 0.54 gives me, let's see, 12,756 times 0.54, and it gives me a number of 6,888.24. All right. So I'm looking for a planet that is similar to 6,888.24. And when I go on my reference tables, the planet, let me just clear this up real quick. All right. Okay. So there's only one planet that has a number that is close to 6,888.24, and that is this planet right here, whose diameter is 6,794. So it's pretty close to 6,088. And what planet is this? Mars. So the correct answer is Mars. That's the correct answer. Mars is the correct answer. All right. So number 15 says, identify the names of two planets in the Kepler 62 planetary system, right? That may have liquid water on their surfaces, and explain why these planets may have water on their surfaces. So identify the names of two planets, not where, not in our solar system, but in Kepler 62 planetary system that may have liquid water on their surfaces, and explain why these planets may have liquid water on their surfaces. So I have a feeling that the reading is going to help me out, right? What does the reading say about planets with liquid water? All right, I see the presence of water in the liquid phase, right? So let's take a look and actually see what is going on in the reading. So it says 5 planets orbit a 7 billion-year-old star, Kepler 62, which has a surface temperature of approximately 4,900 Kelvin. 2 of these planets are located within the habitable zone, which is the region around the star where life may exist due to the possible presence of water in the liquid phase. So they tell us 2 of these planets, right, may have water. Where are they located? They're located within the habitable zone. Within the habitable zone. So 2 of these planets are located within the habitable zone. How do I know what the habitable zone is? Well, let's take a look. When I scroll down, right, and remember, I'm only looking at the Kepler-62 planetary system because that is what the question asks me. The question is only asking me for number 15. It's only asking me about Kepler-62 planetary system. 2 planets in Kepler-62 planetary system. All right? So therefore, I'm looking at 62, and I'm looking for 2 planets that's going to be in the habitable zone only because the reading says right here, right? 2 of these planets are located within the habitable zone, which is a region around the star where life may exist due to the possible presence of water. You got to be in the habitable zone, according to the reading, to have a possible presence of water, right? The gray is the habitable zone. The white is the non-habitable zone. And when I'm looking, the only 2 planets that are in the gray are 62E and 62F. And so your correct answer is 62E and 62F. And one of the reasons you could have said is the fact that they're located in the habitable zone. I'm going to put the answers up. And of course, you can pause, rewind at any time. It's completely up to you. All right, but I'm going to put the answers up to just show you what answers are acceptable. Right here. So the correct answer, you definitely have to say Kepler-62E and Kepler-62F, right? And your reasoning, you could have said they're located in the habitable zone as 1. If you said both of these planets are located at a distance from Kepler-62 to allow water to remain in the liquid phase, is fine. If you said they have the correct temperature, that's fine. If you said these planets have the correct distance from the star, that is also fine as well too. And that is the end of our video. Have a blessed day. Take care.